thanks a million for coming this evening to this Nigma event. The reason I'm saying that is simply because I think there's maybe about 3 different events on tonight, so they lost. No, I'm joking. No, I'm joking. But a big thank you for everyone that came here today. And I think really Cayan have set the bar in terms of drinks. I'm going to be grabbing 2 or 3 on the way out. But anyway, so I'm just going to start off with the structure and how this evening's going to go. And I hope you don't mind, we're sort of live streaming this, but it's probably just me. But anyway, so the structure is just going to go like this. We're going to start off with a quick intro about Cayan, what they do. Next, we're going to go into our top resources with Gillian. So this is Gillian. Say hi. Hi. So Gillian, so we're actually trying to start this top resources thing that we're maybe going to do at every meetup, and it's just really things that we've maybe found helpful. And by the way, like, see if any of you find anything helpful, like sharing's caring. So send it to us or tweet it to us, and we can put them up at the next meetup. But they're just sort of 5 or 6 that we thought would be right and useful. Then we're going to go into our first talk with Paddy Carey, and it's pretty much an introduction to Python. Hands up, has anybody done Python here before? Okay, a few hands. Okay, no worries. And then sort of quarter past 7, quarter past 8, sort of the beer, pizza, refueling and whatnot, and grab more beer. And then you'd think there's something alcoholic in here. There's not that much, but anyway. And then after that, we're going to go into our second talk from Alan Bradley. By the way, a big thanks to our speakers down there for speaking tonight. Well, not yet, but you will. And then at the end, we'll have sort of questions for each speaker, and then we'll just sort of finish up. So first off, if you put your hands together for Scott. From Cayan. So yeah, 100%. What's it? What a minute.
Actually working using it.
It's like the rest of
Hi folks, I'm Scott Wallace. I'm Director of Engineering here in Belfast. I'm responsible for kind of half the feature teams who sit on the other side of the building that probably haven't actually seen yet. But just a bit about Cayan. So we're a private company that was founded in 1998, and our founder is still the CEO of the company. Headquarters are in Boston, offices here in Belfast, and also in Scottsdale, Arizona. We just do payments. We are a payment gateway with our own payment acceptance devices as well. So the Genius platform, the blue touchscreen out here is basically running an emulator that allows you to try everything that the card terminal can do. Some of the new functionality that's only just been released. There's about 140 staff here in Belfast, so that covers engineering and also our call centre. You're on the floor beneath us, and they run 24/7, taking calls from merchants. This is the CED, so this is a customer engagement device. Genius. Belfast is responsible for pretty much all parts of the business. We do development here, our security architecture here. We have the network operations centre, which is the big glass room at the far end. You see on the way out, we've got customer services, all the product here in Belfast as well. And then Genius is basically the flagship product that we do. It's a card terminal, but it allows an awful lot of enhancements to be pushed out remotely. So we were able to accept Apple Pay on the day that it launched, and the merchants who already had Genius didn't have to do anything, it was just there. We pushed out an update that put the Apple icon on the screen for them. Some of the work that we've done over the last year and a bit, the Super Bowl 49 and 50, basically all the merchandise sales for Super Bowl went through Genius. So we actually sat and watched the live graphs on Splunk doing support for it, and it was $2.6 million in merchandise sales. Somebody spent $30,000 on a single item. It was a
You guys just signed Trump, wasn't it?
some sort of signed merchandise from the game. America has just done chip and pin that in Europe we've had for years, and we're all used to. It's only just gone live in America in October. It's causing some interesting things. Americans don't like having to wait and they pay for stuff, so they keep thinking the chip pin is too slow. And apparently we've actually been told that our implementation is faster than the likes of Home Depot and things like that. So we're actually getting business out of how good ours is actually performing. Party City are basically like a Clinton's cards type thing, do party supplies, but they have 900 stores throughout the States, and at Halloween their traffic essentially goes up in a vertical climb. So a number of performance enhancements were done to our own gateway to support them, and we actually ended up having to help their credit card processor in the back end do performance enhancements as well to actually support the amount of traffic. The Apple and Android Pay as well supported whenever they launched, and we're still working with them on some of the stuff that's going to launch coming forward from that. Store Forward is a solution for Party City as well, which allows them to still accept credit cards whenever their internet connection dies. So for some reason a lot of the stores have a pretty bad internet connection, and this allows them to keep accepting seals. Some of the recent outages that were caused upstream from us, they were in your front. Andrew, can you go and get pizza? Drop to? Right, give me 2 seconds. That was fine. So that's obviously Domino's saying the pizza's here. And swipe many times, another feature to try and speed up card seals. And then what it's like to work for Cayan here, we try to promote internally. There's been more than 15 by now. I started as principal software engineer before becoming test architect and then director. So it's the people who've been here for 3 years have gone through multiple promotions. We have hackathons every year. The last one was 2 weeks ago, and we're basically 3 days. We're giving over to the engineers to go and do whatever project they want. I had a meeting this afternoon around some of the projects, and at least 4 of the projects that people have dreamt up just for something interesting to do are going to become real business projects that are going to become features. So an interesting one is anyone been to IKEA recently? On the way out of IKEA, there's a little stand by the door of like sad face, a slightly happier face, slightly happier and a really happy face, and you get to punch what your experience is like. We're going to basically put this on the card terminal. So it's another example of where you don't need a special bit of hardware to do it. We can use the existing hardware they already have to give them a feature, and then we'll be able to give the store metrics as to, clerk number 4 really needs training because he's not doing very well and things like that. Pizza Friday, Beer Fridays, seen the fridge, we're going to see the pizza soon. We have 3 parties a year, a birthday party in May, a summer and a Christmas party, and these can get a bit elaborate. We bust everybody to M&Ds one year for the summer party. Last year we took over the Hilton Brewery and had a load of bouncy castles and sumo shoots and things like that, so it's pretty good fun. And we do loads of other events, so we've got 2 teams doing a relay and a marathon in a couple of weeks, stuff like that, and then there's the benefits package as well. So that's me.
Put your hands together. Alright, so we're just sort of going to go now into our sort of top resources. I'm just going to switch over here for you guys.
While he's doing that, I'm going to do some admin. So the toilets are out the access control doors. There's a number of passes hanging here on the handle of this door. If you need one, just grab it and out you go. There's fire escapes through these double doors here and at the front in case the alarm goes off.
Perfect. Well, by the way, I just wanted to say, is there many new people here, or has everybody been before? Okay, so I'll probably maybe just, you see, I'm just sort of, it's just because we've had a couple that have sort of not done the introduction to Nigma, but I'll sort of just do a quick one. Basically, sort of Nigma came out of the idea of, I was sort of applying for placement in my final year, and I was applying for placement really 2 years ago when I was a second year, and one of the biggest problems that I found was that there's so many different technology stacks out there, and it can be very difficult knowing what to learn. And very often I found myself, wanting to learn, but just didn't know what to learn. And the thing is, with different IT employers demanding and expecting so much, it's very hard to actually know. And so that's the whole idea of where Nigma came about. And I actually was a placement at Install Software and they would be very well known for their Bash meetups that they do. So they're developer meetups for developers, and so I thought, you know what, to be honest, when I started going to them, I sort of found that, you know, the people I was meeting, like, I cannot emphasize enough, if you're a student or if you're just coming into the industry, how important it is to network and just meet other developers, because A, it could lead to future employment, but B, it could lead to starting up a project, which could lead to startups. And all that relates to, you know, you can put on your CV and whatnot, and, you know, see kind of stuff that, like, Forest Labs and, you know, what they're doing, and making sure to get to them meetups. You know, the way I sort of wanted to promote this was sort of, you know, as a student or coming out of the tech industry, the first meetup that you attend, we tend to do introductions of different languages, whether it be Node or Python, and then you can branch off, and if you think, okay, there's maybe Python, I maybe want to attend the PyBelfast meetups that are on, or maybe the Node, if you maybe really like Node, then there's also the Node school workshops that you know, that happen up around Belfast. We'll actually be sort of partnering with Node School later on down the month, isn't it? What date did you say, Alan? It was 21st. Perfect. The reason we're sort of partnering with them is because more crowd. The second thing is as well, I know people are coming up to exams and whatnot, so, you know, it's important, I suppose, putting them priority. And I think that's really it. See, the other see, the other thing I'd like to say is, we're on Facebook, Twitter, #Nigma, but the third thing I do want to highlight is, sorry for this writing, but this, it says nit.rubukuapp.com. Has anybody used Slack here? Yes, some. Slack is really sort of revolutionising the, I don't even know if that's a word, but I kind of made it up, but revolutionising the sort of internal communications of companies and whatnot. It's kind of like developer MSN, but with so much more, with all these sort of different integrations you can do with Jenkins and whatnot. But there's like a fantastic NI Tech and Design Slack team that's out there, and, you know, you've got pretty much every developer in there. By the way, Paddy, it wasn't me that drove the recruiter there. That wasn't me. That was me. But we actually have our own channel there, which is #Nigma. So if anybody does want to join it, let any of us know, send a message, and we can get you in there. Because the thing is, again, it's just like developer MSN. Very often, if I've got maybe a problem, stuck in an issue or something, I actually maybe message. I know I shouldn't, but there's you know, different teams out there. There's different developers within that team. You know, all from Northern Ireland, and again, it's the whole networking and thing that just sort of continues on from that. But then, yeah. So we're just going to go on to the top resources. So if you want to go ahead, this is Jill and Keenan, by the way, everyone.
Yeah, hi, nice to meet you. You can actually read that it does say top 5, but we've actually counted on their 6, so you just got a wee extra one thrown in there. I'm just going to start off. There's one here, freecodecamp.com. You should really check that one out. It's a website yourself, also, and you can go and check that one out. Codeandblocks.net. It's tech podcasts. Personally, I really like the podcast because even if you're in your car, or Connor, I know does a lot. You're in your car, you're driving, listening to a podcast, even just listening to what's going on in the tech industry can give you that extra edge in an interview. There's Code Newbies, the Slack channel that Connor was talking about there.
Yeah, actually, I would just see this Code Newbies one. It's a separate Slack team. Alright, sometimes you can get, so you have like Slack teams, then you have channels within teams. This Code Newbies one was set up by some girl in America, and there's maybe about 4,000 newbie coders, and again they have channels from JavaScript, Node, Angular, you know, whatever it may be, and you can just message people about it if you've got a problem. You know, they even have like just all different types of resources, and then see that free code camp. I tell you what it actually is. Now I came across it on a podcast. What it is it's the best way to describe it is it allows you to start on projects that are open source. They're non-profit companies, and it's a great way if you're maybe wanting to contribute to open source for the first time. It's a great way to start. See, contributing to open source is such a CV increment as well. So if you're maybe applying to jobs and whatnot.
Yeah, and then there's the Crack the Coding interview book. That's what we linked our PDF version of that. It's just good for interviews and stuff, because a lot of the time you'll get technical interviews where you're asked to do programming questions, and that'll just give you that sort of help, you know, for preparing to go into an interview. It's always good to
again, I found this one. So it's actually a GitHub repo of, I mean, there's maybe about 150, 200 PDFs of books from HTML to Scala to Clojure, all that tasty stuff. Again, see all these resources, they will be, if you don't have any of the links, we'll put them up on the Twitter, or if you message us, we have them in our Google Drive.
And then our final one is Team Treehouse, and this is actually, Connor recommended this to me because I got an interview question there that was, what projects have you been working on? And I'm a first year student, so you know yourself, maybe, I don't know, in Georgetown it might be different, but we haven't really worked on a lot of projects. So these are just, Team Treehouse is just a website that you can go on and work on like a couple of small projects yourself and just sort of like get you along and like code and like, you know, learning new things, and being able to talk about something like that in an interview will really help you. So yeah, that's our resources, and they'll be again on Facebook or Twitter, and we'll just post them up for you to just access yourselves.
Perfect. And the actual one thing I want to add with that Treehouse, they actually sent me an email today. Very often with the way the sort of tech industry is going, you'll see that Udemy have started doing like certificates and degrees. No, it's not maybe Udemy, but one of them, Coursera, that you can actually put in your LinkedIn. Treehouse have actually started doing the same thing, which is really cool because they actually take you through full projects with their top quality resources. Like, you're not having to, run around YouTube and, this isn't working. So again, like you said, CV boosters for working on projects and whatnot. That's pretty much all our resources. Put your hand together for Johnny. So we're going to go into our first speaker. So Paddy Carey he's a platform engineer down at ShopKeep. So we actually had Mo at the last event speaking on iOS development. Paddy is sort of the local native down at Forest Labs. So he would co-organise a lot of the PyBelfast, Belfast JS, and then more recently the Go meetups with Alan that they're going to try and put together. And that's Paddy. So if you put your hands together for Paddy Carey. Do you want to start? Aye. Perfect. You just put it and then click it.
Thanks for coming, everyone. I'm Paddy, and this talk's going to be about Python. It's a very general introduction. It's not going to be super technical. I was writing this the other day and sort of thought about 20-25 minutes how deep can I really go. So this talk's going to lean a little bit more towards the philosophical side rather than the technical side, and I hope that's okay. Tell me afterwards if it's not. So who am I? I'm Paddy Carey. I'm a software engineer at ShopKeep. I'm a complete distributed systems nerd. So if you want to afterwards, come talk to me and we'll argue for a couple of hours about the pixels or the capture or something fun. And yeah, just making it all as I go along. And I'm not smarter than anyone. I'm not better at this than anyone. Just make it up like everyone else does. So yeah, I work at ShopKeep. We're a company, we build POS systems. So we are hiring. We're hiring for iOS devs, Ruby devs, Go devs. We have a stack that includes Scala, Java, Ruby, Python, Go, Objective-C, Swift. So, and there's lots to do. We do take placement students, so if you're interested in that, come speak to me afterwards. So, let's get started. What is Python? So, Python's a multi-purpose programming language. It can be used for pretty much anything. We can build servers, GUI applications, command line applications, scripts, video rendering, do big data science with it. We can build games. Just some examples, like some of you have heard of things like Django and Flask. Python web application frameworks that serve some of the biggest websites in the world. Lots of Linux GUI applications are built in Python, less so in Windows and Mac because Python has traditionally a smaller foothold there. Command line applications, if any of you are running Linux or Mac on your computers, you already have Python installed. Most of the tools, or if you're running Linux, if you're running Ubuntu specifically, most of the tools will be written in Python. I can guarantee you that there are Python scripts on your computers. Maybe not if it's Windows, but if it's Mac or Python, you have Python, or Mac or Linux, you have Python scripts on your computer. Lucasfilm do huge amounts of video rendering on massive clusters using Python. Most big companies will use Python in their data science teams, whether that's libraries like NumPy or Pandas for fast computation. And EVE Online, and I'm not sure if any of you play that or ever have, most of the server-side stack is written in Python. A special variant of Python, but still Python. Python is object-oriented all the way down. Everything's an object, or it can be functional. It doesn't really care. Python lets you code in whatever way you want to. It's not strictly a functional language because side effects can happen, but it's possible to write code in a functional style if that's what you want to do. It's interpreted, mostly. I'll come back to that one. Python is strongly typed and dynamically typed. So in Python, you can't add a string and an integer. The interpreter will just blow up. It'll tell you can't do that. And it's dynamically typed. There's no strict type checking at compile time, and you can do magic things at runtime that languages like Go or C or C++ wouldn't allow you to do. So why would you use Python? Python comes with a massive standard library. Batteries included is what we like to say. Almost anything you can need is available already in the standard library. You just import a module, it's there. You don't have to install any third-party packages. You don't have to do a whole bunch of crazy setup. It's just there. Import from standard library and use it. Like I said before, everything's an object right the way down. Functions are objects, classes are objects, strings are objects, integers are objects. Everything's an object right the way down. It has a built-in REPL, or an interactive shell. So a REPL is a read, eval, print lib. And it's just an interactive shell, like the bash shell that you would use on your Mac or your Linux box. But it's in Python. It is really strong introspection built right into the language. So you can look at any Python object, you can inspect its internals, look at its code structure. So nothing's hidden. There are no private methods or private variables in Python. Everything is open. If you can code it, you can reach into it after the fact and get it out and look at it. Python's cross-platform. It runs on every major operating system that there is. I'm not aware of any that don't run Python. If you know one, feel free to correct me. So I mentioned before that Python was interpreted, mostly. There are multiple implementations of Python, and CPython is what you get when you type Python at your shell on a Mac or a Linux box. Probably is what you get. You get a CPython. CPython is an implementation of Python. It's the standard one. It's written in C, and it works. It's okay. Its performance is reasonable. It's fine. It's what everybody uses, though. It's the standard, and it's going to be compatible with everything that you want to do. PyPy is an implementation of Python that's written in Python. It's faster than the implementation of Python that's written in C. That sounds really weird. How can you write a language in itself, which is slow, and make it fast? So it's a whole topic for another talk, but PyPy is JIT compiled, which means that the code is actually, it's not interpreted, it's compiled just in time. And it means that you get almost all the speed of a pre-compiled language, but with all the flexibility and freedom that you get with Python. And these last two, they're not huge, but they do exist and they're useful in some sort. So IronPython and Jython. IronPython runs on the .NET CLR. It's an implementation of Python. I think it's mostly written in VB, I think. But it's embeddable into any .NET program or any other program that runs on the .NET CLR. And Jython's essentially the same thing. It's an implementation of Python written in Java that runs on the JVM. And it was actually, Jython was my first introduction to Python. If any of you remember a BitTorrent client called Azurius, you could write plugins for it in Python. And that was actually Jython under the hood. I didn't realize it at the time, but that's what it was. So, who uses Python? I mean, you hear about Python a lot, and you hear people using it, but you don't really think. You think of it sort of sometimes as a slow language, and well, everyone's using Node to build websites. If people use Ruby on Rails, well, who uses Python? You'd be surprised. It's just a sample of some of the people that use Python for different things, but you can almost guarantee that any big technical companies of any size, they will have Python in their stack somewhere. They might not even realize it, but Python will be in their stack. So YouTube, I believe, is now written in Java. It was initially written in Python, all of it. Most of Google, Google allow their engineers to write in 4 programming languages, as far as I know. So we have Python, Go, Java. I'm missing one. Oh. Python, Go, Java. Oh, C++. Spotify is almost entirely written in Python. Same with Pinterest. Reddit is built on the web.py framework. NASA use Django for all of their web applications. Dropbox, the application that runs on your machine, is written in Python. The backend systems are mostly written in Go now, I believe. Facebook use a huge amount of Python in data pipelines, so performing big ETL jobs to move data from one data store to another, and all that's powered by Python. And Instagram is probably the biggest Django application in the world. It serves more traffic than almost anyone else using Django, and it's a really good poster child for how good Django can be. So, how old is Python? And I think the answer is probably older than most people in this room. So, Python was created in 1989 by Guido van Rossum. Python 1 was released in 1994, so 5 years later. Python 2 was released in 2000. And importantly, Python 2 is what we're still using in most applications, in most use cases. Python 2.7 was released 2008, I think. It was released at the same time as Python 3. And 2.7 is still the most widely deployed version. If you're using something like Google App Engine to host your applications, or if you're using Jython or PyPy or IronPython, then all you have is 2.7. You don't have the choice. But if you do have the choice, if you're starting a new Python application today on a Mac, Linux box, or a Windows machine, use Python 3. Just don't think about it. People will tell you, oh, Python 2.7 is still better supported, there's better compatibility. Just don't use Python 3. You'll thank me later. So, a really trivial example of some Python code that hopefully everybody should be able to understand. So, we have a simple list, contains a bunch of integers, and then we just want to loop over it and print out the ID and the number. So, enumerate is a Python built-in that comes from the standard library. You don't need to import it, and all it does is take a list of something and it zips it with another list that only contains indexes. So this one will come out 0, 1, 2, 3, 4, and then instead of this won't return just this number, it will return an ID and number, and then we just print it out. Again, that's Python 3 syntax. In Python 2, those parentheses will be there, but it's the basic code. So, a slightly more elaborate example. Again, it doesn't do much, but it's just to show you what a real Python application looks like. So, this is a tool, or a screenshot from a tool called ShopKeeper that we built at ShopKeep. It manages the deployment of our containerized applications to a platform called Marathon, which runs on top of another platform called Mesos. And this tool basically allows, it's a re-implementation of the Heroku command line tools in Python. And so it's really simple. You just do ShopKeeper list, it lists all your applications, ShopKeeper config, change the configuration. It's just a little application, and that's just a representative example of what a real Python module looks like. That's the entirety of it, by the way. There's nothing else, there's nothing below here. That's the entire module to list all of our applications. Obviously, it imports a bunch of stuff, but that's the core logic. So, this is where things go a different direction. There was a man called Tim Peters. He's still a core Python developer, and in about 2000, 2001, he came up with this set of principles, a set of guiding principles that distilled how the Python community wrote Python and how the Python community considered Python development, thought about the way they develop Python. Is this a tautology guiding principle for us? I'm not sure. So let's start. First, beautiful is better than ugly. There's not much to say that. Beautiful code is better than ugly code. Explicit is better than implicit. In other languages, you'll import something and something will happen. You'll call a bit of code and something magically over here will happen, or you'll initialize a class that the language or the framework just knows how to use and everything's magic. That doesn't happen in Python. Everything is explicit. Nothing happens unless you tell it to. Every single time you have to tell it what to do. Simple is better than complex. I don't think anyone can argue that. Simple code is better than complex code. Nobody wants complex code. But complex is better than complicated. Sometimes complex code is necessary. You have a complex problem, you need to write complex code to solve it, but it doesn't have to be complicated. So those 4 items, they boil down to what I believe is Python's simplicity. So beautiful is better than ugly. Write your code for humans, be consistent. Don't change your style halfway through writing a project. Python allows you a lot of freedom and allows developers to do pretty much whatever they want. But there are style guides, there are guidelines, and it doesn't matter if you choose a different style, be consistent with it. And always assume that other people are going to come behind you and read your code. People who have no context on it whatsoever. Explicit is better than implicit. Again, just be clear. Don't write APIs that do magic things in the background. If you want someone to call a function, make them call a function, don't call it for them. Simple is better than complex. Keep it simple, stupid. Memory management is completely memory managed. You don't need to worry about allocating RAM and freeing it. It's garbage collected, so that memory will be free for you. You need to manage complexity, and you want to reuse existing libraries and packages. So instead of rewriting a HTTP library for the 10 millionth time, just download the one that already exists, use it. Don't write another web framework, just use Django or Flask. You get the point. So, next step. Flat is better than nested. So, any of you that have seen much Python code, and in the previous examples, you'll see Python uses indentation to define code blocks. So there's no curly braces in Python at all. You just can't use them. You use indentation to mark out a block of code. And a good rule of thumb is that your code should never be nested more than 2 levels deep. It just makes it easier to read and makes it easier for people to follow. Sparse is better than dense. So don't just write 100 lines of code with no line breaks, with no spaces, no anything. Python's style guides, the most common one is called PEP8, and it provides a set of guidelines that allow Python developers to style their code in the same way as every other Python developer. And it enforces things like spaces before and after operators, spaces between items and lists, 2 line breaks between function calls, those sorts of things. And it makes Python really easy to read when you look at it, and there's no massive density there. Again, readability counts. You're going to read any code that you write 100 times more than you're writing it. So you write it once and you'll read it 1,000 times. If it takes you an hour longer to write something that's more readable, do it, because you'll save yourself 100 hours in the future. Special cases aren't special enough to break the rules. This is a really important one. I mentioned that everything in Python is an object, and at times that doesn't really make sense, but it has to be a really special case to warrant breaking that everything is an object rule, and that's consistent throughout Python. Where there are rules, unless there's a really, really compelling case, it's not enough to break rules. Although practicality beats purity. So if you need to, you can. So those 5 again, they boil down to about how readable Python is. So flat is better than nested. You want a consistent coding style, and you don't want to have to scroll right in your editor to read a line of code. It just makes it difficult and makes it harder to comprehend what's on the screen in front of you. So you want to use functions and objects and refactor your code so that you don't have huge nested blocks of ifs. In other languages, it might be okay to do that because you can use curly braces and avoid that massive indentation, but in Python you can't, so it's really important. Another part of that is that the Python style guide PEP8 actually enforces an 80 character line limit. So if your line of code is longer than 80 characters, I mean Python will still run, it's fine, but your editor will probably tell you it's bad style. And that restriction really plays when you think about this. So if you have more than 2 levels of indentation, it specifies 4 spaces for indentation. So you lose 8 characters, you have 72 left to write with and play with. Any more levels of indentation, it's going to get difficult to actually write code. Sparse is better than dense, so we want loose coupling, separate modules. The Unix philosophy of doing one thing and doing it well, just try and keep that in mind when you're writing code. Readability counts. We want significant white space, no brackets. Documentation is also really important in Python. Python allows you to write a doc string for every function, every class, every variable, and then there are tools that will extract that documentation and display it in a nice human readable way that people can use. Again, documentation in Python is written for humans, it's not written for machines. We're not building automated documentation that you can build an API client from. We're writing something that someone can read and understand. So special cases aren't special to break the rules. I mentioned everything is an object, no exceptions. Although practicality needs to be reviewed. If you need to, just break it, doesn't matter. So Python talks a lot about this stuff, and Python doesn't follow these rules itself, but that's okay. They're aspirational goals, less so than hard and fast rules. So errors should never pass silently. A common idiom in Python land is that it's easier to ask forgiveness than permission. So if you want to do something in Python, you just try it, and it might throw an error. That's the way you do it. You catch that error if you want to deal with that flow and use exceptions for control flow. Never, if you're going to use Python, don't check if you can do something first. Just do it. It'll throw an error if you can't. Checking for, say you want to check for the length of an array before pulling an element from it. If you do that in a threaded system, there's a race condition there because you can check, you can change before you get the chance to take it out. So just try it. If it's not there, you'll get an error. Unless an error is explicitly silenced. So you can in Python tell it, don't throw this error or catch this error and do nothing with it. But exceptions should be allowed. If something wrong happens in your code, it shouldn't just go, oh, I got the wrong thing back from that function. I'll just continue on anyway. And that's what happens in a lot of languages. It's really difficult to manage control flow with exceptions in a lot of languages. A lot of languages explicitly don't allow you to do that and tell you not to do it, but Python fully embraces the exceptions as control flow part of them. This is another really important one. In the face of ambiguity, refuse the temptation to guess. So when the Python interpreter comes across a situation that it doesn't understand, whether it's trying to add a string to an integer, it won't just convert one to the other and add it, because that might not always be right. It'll just go, I can't do this, exception, somebody else's problem. There should be one, preferably only one, obvious way to do it. So everything in Python, like every other programming language, probably multiple ways to do things, but only one of those should be the obvious, blessed, officially sanctioned way to do it. So a good example is, if anybody's done any functional programming, something like the map primitive, which applies a function to every element in a list or an array. There is a map implementation in Python, but it's not the right way to do it. It's not the obvious way to do it. The obvious way in Python is something like a list combination, which is a Pythonic construct that allows you to iterate over a list and do whatever you want. Although that way may not be obvious at first unless you're Dutch. Guido van Rossum is our benevolent dictator for life, and he always will be, and he's Dutch. I can't really explain that one anymore. So those 5 items, they all point, for me, towards Python's predictability. So errors should never pass silent. You know if you do something wrong, you will get an exception, unless explicitly silent. So catch those exceptions, use tracebacks, log errors, do whatever you want, but only when you're explicitly silencing them. Again, refuse the temptation to guess in the face of ambiguity. A+1, that won't work. I think it probably will in Java. There should be one, but preferably only one obvious way to do it. Don't reinvent the wheel. Use existing libraries. Read other people's code. Figure out how they've done it. Don't try to do it yourself again in some weird way that somebody coming behind you is not going to understand. So, again, in Guido we trust. Guido sometimes comes along, decides that somebody else has implemented something in a strange, unPythonic way, and he rewrites it himself. But that's okay. He's Guido. We can't do anything about it. It's his project. So, now is better than never. It's really common in software projects to get bogged down in details, to spend weeks and weeks and weeks worrying about the colour of the bike shed rather than actually building the bike shed itself. So it's a real issue, and in most cases, the less than perfect solution that you have now is probably better than a hypothetical perfect solution that never happens. And Python takes that to heart. A lot of Python's internals have been built that way, and they've just been iteratively improved over time. A really, really good example of that is Python 3. If anyone's ever used Python 3 before Python 3.5, they'll know that it was far from perfect. It caused a huge chasm, a huge split in the Python community. About half of the community is still on Python 2, half is on Python 3, and it's just become a running joke on like Slashdot and Hacker News and all those things. Slashdot still exists, show my age. Although never is often better than right now. So if you don't have a great solution, if it's not even close to perfect, just don't do it. I mean, sometimes you have a choice. You need to do something either right now, or you need to get something out the door right now. But it's often better just to go, well actually, no, we could release something substandard now, or we could just never release that substandard feature to our users and actually have them users start complaining and have to support it. So just don't do it. I like this one. If the implementation is hard to explain, it's a bad idea. I can't think of an exception to this. I sat for ages the other night trying to think, can I think of an exception to this one? And I can't. If you can't explain it simply enough, then you don't understand it well enough to implement it. If the implementation is easy to explain, it might be a good idea. It doesn't mean that it is. It may be. It's certainly easy enough to explain. You probably understand the problem well enough. Doesn't necessarily mean it's a good idea. And the last one. Namespaces are one honking great idea. Let's do more of those. So, in Python, when you import another package, whether it's a third-party package or from the standard library, you import the module name. So say it was requests. Requests is a HTTP library, allows you to make GET requests, post requests and stuff. So you would import requests and then access anything within requests as request.get, request.post. You can also, when importing a Python module, do from requests import star, and then everything within the request module will be available in the global namespace. And that's great, it works, but it becomes really difficult to trace the source of those keywords, of those names, of those functions back to where they actually came from. And if you do that more than once in a single module, you'll have all these things from 7 different packages all in your global namespace. What if they use the same function names? What if library A has the same class name as library B? Which one do you get? Who knows? So those 5, to me, they all sum up Python's practicality. So now is better than never. Perfect is the enemy of good. That's Python 3. Although never is often better than right now. The PEPs can be rejected. A PEP is a Python enhancement proposal, and every change, every improvement, every deletion or deprecation that happens in Python goes through the PEP process. So it has to be written up, described, voted on by the core team. And sometimes they get rejected just because there's no agreement. People can agree that something is a great idea, but without an agreement on the implementation, it's probably better just not to ever implement it. Be patient, wait for the right solution. If you can't explain an implementation simply enough, then you don't understand it well enough. I think that's pretty self-explanatory. If the implementation is easy to explain, it might be a good idea. And namespaces, there's the example I was showing you. So if you're importing the bar object from the package foo, then import it as bar, and then you can call bar.new, bar.whatever. Or you can do from foo import, and you can just call bar. It'll be there. But you'll have trouble tracing it back to where it came from. So, in conclusion, Python is simple, Python is readable, it's predictable, it's practical, it's easy to learn, and it's fun. Thank you.
Guys, we'll maybe have time for maybe 2 questions because I know the pizza's there. I know one question. See, in terms of if somebody wanted to start using Python, would you tend to recommend just using text editor or an IDE? Like, because I know JetBrains have PyCharm, isn't it called?
I've never had much luck with IDEs. I use Vim or Atom these days.
Yeah.
And they're both fine. Just use a regular text editor. If you want to use an IDE, fine. Whatever. Use whatever works. It doesn't matter. If that's Notepad, fine.
Does anybody else have any questions?
You just got to find it acceptable if the editor's Emacs. Yeah, you're right.
Alright, that's everything. Alright, listen, pizza's ready, so I'm sure you all are hungry. So we should get dinner. Alright.